Now we shall discuss some harmful effects of specific pollutants like CO, CO2, SOx, NOx. SOx represents the oxides of sulfur, NOx represents oxides of nitrogen. Now, first of all, we will discuss harmful effects of the pollutant carbon monoxide. The carbon monoxide is poisonous as it combines with hemoglobin of red blood cells about 300 times faster than oxygen, thus forms carboxyl hemoglobin. Basically what happens is, it is a complex formation reaction. Carbonyl is a stronger ligand than O2. So the strength of the complex with carbonyl ligands would be much higher as compared to that with oxygen ligands. So, as given, the hemoglobin of red blood cells makes 300 times faster than O2. That is, it makes complex with hemoglobin 300 times faster than O2. And this carbonyl complex is harmful in nature. Hence, it is very poisonous for the human body. Now, next we would be considering CO2. CO2 causes narcotic effect, stimulation of respiratory center, and leads to asphyxiation. Narcotic effects. What are narcotic effects? We know narcotic drugs, like which do not let us respond to our external stimulus. Narcotic means these do not provide inflammation. The increasing concentration of CO2 also changes climatic conditions, especially by raising the general temperature. So we move on to oxides of sulfur. Now, what do oxides of sulfur do? Oxides of sulfur basically causes cough, shortness of breath, spasm of larynx, acute irritation to the membrane of gas, resulting tears, and reduces hearing ability. So basically, each of the oxide present as particulate matter in air has some of the other negative effects on the normal functioning of human body. Now, oxides of nitrogen. NO is biologically less active because NO is the most stable oxide of nitrogen. This is the reason for this. Now, NO is less toxic than NO2. Like CO, NO binds to hemoglobin and oxygen transfer the efficiency of blood decreases. Inhaling of nitrogen oxides pulls mononeuric edema and hemorrhage. Oxides of nitrogen cause damage to plants as well, and sunlight reacts with NO2 to produce highly active oxygen atoms, that is NO2 in presence of H nu, which is sunlight. It will break out as highly active oxygen atoms, which is nascent oxygen. This will give nascent oxygen plus N2. So these are all the harmful effects. Now we shall discuss the global concern presently, that is the stratospheric pollution, which includes majorly ozone layer and its depletion. Ozone layer basically protects us. Ozone layer is a thick layer of O3 molecules present in the stratosphere at about 25 km height from Earth's surface. Now, ozone layer protects us from the harmful effects of UV radiations. What are UV radiations? These are ultraviolet radiations, which are a component of the sunlight. Sunlight composes of UV plus visible plus infra majorly, as well as some other radiations. Now, the UV radiation on exposure to skin causes skin cancer and also damage to immune system. From recently, it has been found that ozone layer is thinning due to influx of oxygen gases as NO2, SO2, etc. And this thinning of ozone layer is especially near the poles. So this thinning of ozone layer is a major concern in the present world, and it has led many of us to think, are we going on a right path? So next is acid rain. Acid rain basically consists of acidic oxides in air which combine with water, thus forming acid rain. Acidic oxides are such as SO2, nitrogen oxides, and acidic soot. Sulfur dioxide and nitrogen dioxide react with water vapors in presence of sunlight to form sulfuric acid and nitric acid units. As we have seen, SO2 plus H2O gives H2SO3. This is acidic in nature, so it causes the rain to become acidic. Now we would study about the greenhouse effect and the global warming. Now, what is global warming? Global warming is actually heating up of Earth due to the presence of thick layer of carbon dioxide, methane, etc. gases present above the Earth. So, this heat, global warming is the consequence of excessive greenhouse effect. Greenhouse effect is basically due to presence of CO2, CH4, etc. gases in the Earth's atmosphere. They trap the heat and cause global warming, that is, globally warm up the Earth. They catch the heat in them. Now, global warming has various advantages as well as disadvantages. So, first we'll discuss the advantages. Now, global warming is necessary for evaporation of water, formation of clouds, rainfall, etc. But there are hell lot of harmful effects of the greenhouse effect. Of excessive greenhouse effect, that would be the correct word. So, these harmful effects are the change in ocean temperature, the high temperature, which may reduce the crop productivity. High temperature of atmosphere may melt polar ice caps, so they are likely to raise the level of sea, which would cause floods and affect the coastal areas. The tropical rains and hurricanes are also a consequence of excessive greenhouse effect, which become more frequent when greenhouse effect exceeds a certain limit, and also are stronger, thus causing larger devastation. Moving on, we now focus on water pollution. Now, what is water pollution? Basically, the contamination of water over a certain limit causes water pollution. Water pollution may be due to various reasons, such as spilling of oil, letting out of the industrial untreated waste into water bodies, then by various human activities, by some of the animals' activities, etc. So, water pollution has various causes. Also, it has large devastating effects. If water resources are in shortage, then entire human race as well as the animals, plants, everyone on this earth would face scarcity of water and thus would endanger their life. So, to prevent water pollution, we must take various measures in order to save our lives. So, first, an important term in water pollution is defined as the biological oxygen demand. So, basically, let's get into this. What is this biological oxygen demand? It is basically the amount of oxygen in ppm. What is ppm? ppm is parts per million. Like say if you require 10 gram of oxygen per 10 raised to 6 gram of air, then ppm of O2 would be 10 by 10 raised to 6 into 10 raised to 6, which is 10 ppm. So thus ppm is defined. Now what is biological oxygen demand? It signifies the demand of oxygen by biological species. It is the measure of total contamination caused by compounds which can be oxidized in the presence of microorganisms. So, what amount of contamination is caused? Basically, let us say we'll consider the examples of the aquatic plants and animals. So, whatever amount of oxygen they require to sustain their life, the minimum oxygen required to sustain their life, that is known as biological oxygen demand. So, biological oxygen demand is calculated as cumulative thing and is given out to be a single value. Now, the biological oxygen demand is taken as a realistic measure of water quality, clean water. So, that is, if there is greater biological oxygen demand, implies more number of organisms live in the water, because water, that is, oxygen requirements increase. So, more organisms present in that water body. This implies the water body is clean and sustainable for growth and development of living things. Now we would focus our attention on land pollution. Basically, what is land pollution? Land pollution is deterioration of land piece due to pollution caused. There are various sources of land pollution, and land pollution results mainly because of lack of space. Land pollution. People litter on the roadside. The improper waste management by the municipal corporation or by the government. The waste produced by animals, etc. All these contribute to the single term, that is land pollution. So, also there is one term, that is the insecticides and pesticides which are sprayed upon the crops in the fields to prevent them from being infected by the insects. But what devastating consequences does spraying of such insecticides have on land? Basically, land pollution increases because of that. As insecticides are sprayed on crops, they get accumulated on land and they can be consumed by another organisms which may be harmful to their body and may cause their death. So, land pollution. In land pollution, we would be discussing about insecticides. Insecticides help to curb disease and protect crops by controlling insects. That is, we are controlling insects to curb diseases and protect crops. So, examples are DDT. But what negative impact such insecticides have is that they are non-perishable, that they are non-degradable. They cannot be degraded by biological mechanisms. So they accumulate in the environment. As they are harmful, even if as they're harmful, whenever they get consumed by any organism, so that organism may be in danger because the degradation of such insecticides doesn't take place in his body and hence remains accumulated and may be poisonous for his life. Now we need to remember the structure of DDT, which is diphenyl trichloroethane. This name is to be remembered and the structure is very, very, very important.
Okay, so now we're starting with the questions of environmental chemistry. The first question goes like, which of the following are used for softening temporary hardness of water? Your options are Ca3PO4 whole twice, that is calcium phosphate, CaH whole twice, calcium hydroxide, Na2CO3 sodium carbonate, NaOCl, that is sodium hypochlorite. Okay.
So now we proceed to the solution. So as you see, the solution is painted. Clearly, we know that hydroxide are basic in nature, and the hardness of water is due to say calcium hydrogen carbonates, and like some hydrogen carbonates which are soluble in water but actually are harmful for human beings, and for actually the water is not potable in that sense. So the hardness of water is actually due to the presence of soluble hydrogen carbonates in it. Bases like CaOH twice and Na2CO3 are basic in nature. Hence, the reaction with the reaction of calcium hydroxide with calcium hydrogen carbonate yields calcium carbonate plus twice H2O. Here, calcium carbonate gets deposited. That is, it is precipitated out. So the hardness of water is removed. In this way, answer comes out to be B and C, because both Na2CO3 and CaOH twice are basic in nature and can react with CaHCO3 twice to cause its precipitation.
Okay, so this concludes question number 1. Alright, now we're going to do question number 2. Question number 2 कहता है, which of the following gas or gases cause the rain to become acidic? तो ऑप्शन है आपकी A NO2 नाइट्रोजन डाइऑक्साइड, B CO2 कार्बन डाइऑक्साइड, C मीथेन या फिर CH4 और D H2O vapor.
So now let's get started with the solution. Here we know that only those the gases which are present in atmosphere, if they are acidic, they would react with water to form acids. So these acids make the rain acidic. So only those oxides which have acidic character in it, that is, on reaction with water, they produce acids. That would be causing the rain to become acidic. That is, they would cause acid rain to fall on earth. So now we know this reaction, that NO2 plus H2O gives acid, CO2 plus H2O gives carbonic acid, this above one is a nitrogen acid. The carbonic acid has molecular formula as H2CO3. So again we know that CH4 is highly stable and will not react with H2O, so no reaction. And now H2O vapor would not have any reaction with H2O, that is, it is neutral in nature, so it cannot produce acid, so no acid. So only NO2 and CO2 produce acid on reaction with water, so our answer becomes NO2 and CO2.
Okay.
That would cause the acid rain.
Okay, so एक चीज है, NO2 जब H2O के साथ रिएक्ट करेगा, जो नाइट्रोजन एसिड बनेंगे वो HNO2 और HNO3 नहीं होंगे, वही होने चाहिए मोस्ट प्रोबेबली.
हाँ, वही होने चाहिए. Actually, it is HNO2
plus HNO3
plus HNO3.
So that concludes question number 2. Now we move on to question number 3. Okay, it seems like a very interesting question. The question reads, out of the following compounds, how many have color blue or dark blue or violet? So these are the compounds which are there in the options. First is iodine, then we have copper hydroxide, COH whole twice, then we have ozone, then we have NO, then we have N2O3, then we have azurite, and then we have PBS. So which of the following are blue or dark blue or violet? Let's find out.
So now let's get to the solution of this problem. Here we know that iodine I2, which exists in solid state at room temperature, is violet in color. Also CuOH twice, which occurs as aqueous solution, is blue in color. Ozone is blue-black in color. That is, it is blackish blue, so it is very near to violet. Blue-black. NO has brown color. N2O3 again has blue color. Azurite, as the name suggests, the azure color is actually the blue color, like near to blue. So azurite is an ore of copper, which is CuCO3, 2CuCO3.CuOH twice. So it is blue in color. And PBS is galena, which is the chief ore of lead, which is black in color. So among the following, we have blue colored compounds as azurite, N2O3, ozone, COH twice, and iodine. So total 1, 2, 3, 4, 5 compounds. So answer would be 5.
Okay, hence we conclude the question and the answer is 5.